Hi guys, welcome back. This is my Calculus 1.2 video for limits graphically. So you're asked to evaluate a limit by looking at a graph. So one of the things, and I've got two examples here of how we're going to do this. One of the things that's common with limits is being able to look at a graph and separate the calculus part, which is the limit stuff, with the algebra part, which is the function notation. So let's talk here again for this first set in green right here. We're going to approach 1 from the right. We're going to approach it from the left, and we're going to see what it is overall. Remember that the left and right have to be the same for you to have an overall limit. Okay. If the left and right aren't the same, this will always be a DNE answer. Okay. So we're looking at approaching 1. So 1 is right here. This is 1. So I'm just kind of put like a little or vertical line here as we approach 1. So we look at the graph from the right. So the right side of 1, the graph is right here. And as we approach 1, as we get close to 1, the graph, y value wise, converges to -5. All right, so our answer here is going to be -5. What is it as we approach from the left? So as we go from the left, we sit here and we follow the graph as we approach 1, and the y value here is at -1. Now, maybe some of you are thinking, all right, what about the open and closed circles? When it comes to limits, that actually doesn't matter. That's going to be more with the function notation on where the function is defined. If you remember from the notes, just because a limit exists does not mean the function is defined there, okay? And so now we finish this off here. The limit from the right of 1 was -5. The limit from the left of 1 is -1. Those aren't the same. As you can see, as we converge from both sides, we don't converge to a single y value. So therefore, overall, this limit does not exist. Okay. Let's do another one here in the light blue as we approach 0. So 0 is right here in the middle. All right, so this is 0 right here. What happens as we approach 0 from the right? All right, as we approach 0 from the right, looks like we're going to be right there at 1. And again, that open circle doesn't matter. What about 0? This should be from the left. That should be from the left. From the left side, well, it looks like 1. And then overall, since these are the same, you can see that as we approach from the left and the right, or actually if we actually tracing with our fingers are coming together. They're coming together at 1. All right, so there's two examples with limits. Let's go to the function notation because a lot of times people tend to get a little confused with this. So let's just review some stuff here. We got f of 0. Where is this function defined at x equals 0? Where do we have a solid line or a solid dot? So right here at 0, where are we defined? Well, the limit was at 1, but it's an open circle. We're defined actually at 2. 0, 2 is actually a point that's on that graph. What about f of 1? F of 1, well, where are we defined here at f of 1? We're actually defined at -5. So 1, -5 is on that graph. What about -1? -1, well, solid line right there. It looks like 2. What about f of 4? F of 4, here's x equals 4. What's the y value? That's -3. And then last, -5. We got an open circle, can't use that one, but we do have a solid circle or a solid dot right here, and that's at -5. So there's one graph where we did limits from both sides and we did some function notation. Let's do one more. All right, so again, we're going to look at 1 from all three sides. So 1 from the right, well, that's going to go up. We actually have an asymptote here. That line is not going to get crossed. when we look at this. So from the right, that thing, the graph is shooting up. This is actually going to positive infinity from the right. What about from the left as we approach? It's going down. So this is going to approach negative infinity. Since from the right, it's going up to positive infinity. From the left, it's going down to negative infinity. Those aren't the same. So we know that this is does not exist for this one. I messed up the notation here again, but that's okay. We'll talk about this here. We want to know -3 from the right. -3 from the right side. So again, here's -3 right here, right? Okay, here's the graph as we approach from the right side, and now we have an open circle, but remember, that doesn't matter for the limits. So as we approach from the right, the y value is 5. Now, if we want to change this here just to the left, what's the limit as we approach from the left side? So we follow again, and all right, as we approach, we're going to get 5 again. The right side and the left side are 5. That means overall, get rid of the little plus sign, just overall, since the right side and the left side approach 5, the overall limit is also 5. Okay? And let's do some function notation again with this one. So f of 0, where are we defined at 0? 0 looks like about 3.5. What about f of 1? F of 1 had an asymptote on it. Now, this is important. We are actually not defined at 1. So a lot of times people get confused. They'll put DNE. Actually not defined. So we will put undefined at f of 1 because we have an asymptote there. What about f of 5? F of 5, solid dot over here at 5. And then -3, again, solid dot, not the open circle. F of -3, we actually have the 0.7. So hopefully those two quick examples will help you when you're trying to navigate evaluating limits or function notation by looking at a graph.